Hi there, friends and families. My name is Mrs. Reiner, and I teach STEAM at Beaumont Magnet Academy. This is Activity 2 for Science for 2nd grade. Activities and handouts can be found under the Student Resources tab on the Knox County Schools website at www.knoxschools.org. You could also show us what you've learned with this activity and tweet at KCS Science. If this video is at all hard to understand, we have a few options here to help. You could turn on closed captions, if available. You could adjust the playback speed to slow down the video. You could consider watching this video in shorter clips. That way you can pause and listen and watch again. You could also ask someone in your home, like a grown-up or a sibling, to watch the video and do the activity with you. Then you can stop frequently and talk to your partner about what you've heard and understood. Now, in Activity 1, you learn all about force and how a force is used to make objects push or pull. Remember that a push is a force that moves something away from you, and a pull is a force that moves objects closer to you. Now, right now, these all seem like very simple movements. What if I said I could change the way that they look, though? I know you're thinking, how do you change a push and a pull? Well, a push and a pull move in one direction because there's nothing in their way. But what would happen if I put something in their path? For example, another toy car in the picture of push. Or what about another train in front of the one for pull? What would happen then? That's right. Those two objects would meet and they would do this. They would collide. When objects collide, they meet or come together. In this video, we'll explore what happens when objects collide. And we'll also explore how the forces used for push and pull can change the outcome of the collision, or what happens after those objects collide. Go ahead and take a look at this picture here. We have two friends, Alex and Chandra. Now, they like to play with cars all the time, and they're always pushing their cars around. But one day, as they were thinking and playing together, they decided they wanted to know what would happen if they pushed the cars towards each other. Well, they both have different ideas on what will happen after. Alex thinks that the cars will continue to move in one direction. And Chandra thinks that the cars will change direction. Who do you think has the better thinking? We're going to keep that in our brains as we watch this video and do our activity and see if we still have the same idea. What do you think of when you see these words on your screen, like come together, collision, and collide? I bet a lot of you think what I think of when I hear the word collision, and that's this, when two cars collide together, right? Well, that's pretty dangerous, isn't it? And while this is a collision, in truth though, cars aren't the only things that can collide together. Remember, when we collide, it's when two things meet or come together. In fact, we collide with things every day all around us, and we witness collisions too. In fact, we collide our hands together every time we do something as simple as clapping when we see something we really like. Let's take a look at some of these other examples that I have to show collisions, and you'll see what I mean, that not every collision can be dangerous. In this picture, we have a volleyball match. Looking at this picture, can you see where the collision is about to happen? That's right, her hand is about to collide with the ball, or her hand is going to meet the ball, right? Let's see, here's this picture. In this picture, we have someone bowling, and the bowling ball is going down the alley toward the pins. What two objects in this picture do you think are going to meet or collide? Yes, the bowling ball is going to collide with the pins. And this picture here is of a softball game. And we have a collision happening. Where's this collision happening? That's right. The softball player wearing red collides with the softball player wearing black. But guess what? I see another collision taking place here too. In softball, just like baseball, there's 3 bases that you have to run to. And it looks to me like she's sliding into one of those bases. Well, if she's meeting it and her and the base are coming together, that's called a collision, right? So as you can see, that not all collisions are dangerous and not all collisions have to be something scary. What I'd like to know though is what happens to the objects after the collision. Looking at these 3 pictures, we can see a collision about to happen and we can see a collision actually happening. But we don't see any pictures of what happens after these objects all collide. What do you think happens to these objects after? Do you think that they just stop? Do you think they keep going? Or who thinks they change direction? Let's keep going to find out. Check out this picture. I want to know, what do you see? What do you notice in this picture? I see a building, but I notice that a lot of parts to this building are missing. I think this building is being demolished or taken down. That takes a lot of pushes and pulls. Are these pushes and pulls that we could use? No, I don't think we could pull this building down with just our hands. We're going to need more force than that. Think about the amount of force that this would take. Who was able to do this? Well, if we don't have enough force to pull down this building with our hands, what else could be used? Think back to our bowling ball picture and of that collision. Now, a bowling ball is pretty heavy, which means it has a lot of force behind it, and you have to throw a bowling ball pretty hard to get it down the lane. Would it knock over as many pins if we were to use a different ball, like a kickball or a bouncy ball? No, we wouldn't have enough force to do that, right? Well, let's find out who and what actually did this to this building. This is our who. This is Jim. Jim is a construction manager. It's his job to determine how we can use collisions and forces of pushes and pulls to knock down old buildings. And he uses the same information to build new ones. Take a look at Jim. Think about the type of force you'd have to use to knock down a building. And what sort of tools, what sort of collisions do you think he would be able to use? I'm thinking about his job, and I'm thinking that he probably uses a hammer. And so the collision there would be his hammer hitting the wall, or if he uses it for nails, it would collide with the nail. Do you think he knocked that building down, though, with just a hammer and some nails? Or his hands? No, like we said before, he would need a lot of force. Those were really big pushes and pulls. Take a look at this machine, this tool right here. This is a crane. Jim uses this crane when he doesn't have enough force on his own. This machine can make bigger pushes and pulls, so the collisions that take place can make objects move farther. Now, Jim works with collisions the whole time he's on a job site. When he's taking down a building and putting it up, he uses a lot of these same tools to be able to pull and pick up materials to put the building back together or build a new one. Do you think you could be a construction manager? You're about to find out. It's time for you to practice being a construction manager, and this will be your building. The materials that you're going to need for this activity are 10 cups, paper or plastic, that you can stack, and 1 ball. Now you can use any material to stack your tower if you don't have cups. Some ideas that Mrs. Reiner came up with was building a tower or a building out of Legos. You could also use cardboard tubes or old soda cans or bottles. Now keep in mind, we are going to rebuild this tower at least 2 times. So if you build something with Legos, I wouldn't make it too fancy. Go ahead and go grab your materials for this activity. You can always pause me and come back and press play when you're ready. Okay, now that we're ready, you should have your materials. Don't build your tower just yet. Don't set up. We have to talk about something really important first. It's always good to make a prediction because you'd like to think of an idea first. Always have an idea in your head of how you think things are going to work out. That's called making a prediction. So we're going to predict what will happen if we use our materials to make a tower and then give a ball a gentle push into the cups. Go ahead and make your prediction. If you're writing your prediction down, again, pause me and resume. That's okay. We can do this video in clips. All right, I want to know, what did you say will happen to our cup tower when you give the ball a gentle push? Oh, I'm so excited. We're getting ready to find out. First, we have to build our tower, and we're going to build our tower with 10 cups. Now pay close attention because the way that this tower is built is a bit different than you might have built a tower at school. We're going to use 6 cups for our base, and I'd like for you to put your 6 cups in the shape of a triangle, just like my blue circles on my page. When you've got your 6 cups for your bottom layer, we're going to take 3 more cups and we're going to stack them on top like this in a smaller triangle. Remember, 6 on the bottom, 3 in the middle. And then you should have 1 cup left, and I think you can figure out where that's going to go. Yep, right on top. Good problem solving. All right, let's take a look and see what happens. Now you're doing this activity at home, hopefully, but you can always use my video as well. Let's see what happens when we give the ball a gentle roll. Notice how we just tapped the ball. We didn't give it a strong push. We just lightly rolled it. Okay, and it's important to make sure you take note somehow of what happened after the gentle roll. If you're following along on the activity sheet, there'll be a place for you to draw a picture of what your tower looks like. Other ways of keeping track would be to count how many cups have fallen. You could even put a line and measure. See if you moved all the cups back a little bit further. Okay, now it's time to rebuild our tower again. I know, we have to rebuild it, but hey, once we rebuild it, we can knock it down again. And this time's going to be a bit more fun because you can use a harder push. So let's rebuild our tower using our 10 cups. Remember, start with 6 on the bottom layer, shaped into a triangle just like my blue circles on my page. Then you're going to use 3 more cups for that middle layer in a smaller triangle. And if you remember, you can whiz on past me, that's fine. And then remember, that last cup goes right on top. Now it's time to give our ball a harder push, so we won't be as gentle as we were the first time. It doesn't have to be a big difference, but definitely push it harder than you did the first time. And let's see what happens. Ooh, what did you notice that time? Did something else different happen? It wasn't exactly the same as our gentle push, was it? No. Let's see. Now, which push made a bigger change to our tower? Did the gentle push make a big change? What about after the harder push? Did we see a bigger difference take place? What did you get? Oh, this is really, really good. I love our observations. Now that we know more about collisions, and we know that a collision is when we make things meet or come together, we can revisit Alex and Chandra and help them with their problem. Now remember that they decided to push their cars towards each other one day, but they both disagree on what's going to happen after they collide. Alex thinks that the cars are going to continue going in the same direction, and Chandra thinks that they're going to change direction. Who did you agree with the first time you saw this problem? I think I might have too. I want to know, did your thinking change? Do you disagree now? Do you think somebody else had the better thinking? Thank you so much for joining me for this activity. I had so much fun learning all about collisions and how they can change objects depending on the force that they use. Please share pictures of your tower and of your activity sheets if you've chosen to do them with the video, and share those on Twitter with a grown-up's help, of course, at KCS Science. Thank you.